Picture this, the vast, endless expanse of space, a universe teeming with the hum of pulsars, the crackle of solar winds, the distant echoes of colliding galaxies. It's a cosmic symphony, a never-ending broadcast of light and sound traveling across the void. But what if I told you there's a place where this symphony goes silent? A pocket of the universe so eerily quiet, so utterly devoid of signal, that it defies everything we know about the nature of space itself. Welcome to the Silent Zone, a mysterious sector where no signal escapes, where the laws of physics seem to bend, and where the universe holds its breath. This isn't science fiction. It's a real, documented phenomenon that has left astronomers and scientists baffled for decades. Imagine sending a message into the void, only for it to vanish without a trace, as if swallowed by an invisible hand. No echoes, no reflections, no way to trace its path. The silent zone doesn't just absorb signals, it erases them, leaving behind a void so absolute that even our most advanced technology can't penetrate its secrets. What could possibly create such a place? Is it a natural anomaly, a cosmic quirk we've yet to understand? Or could it be something far more unsettling, something that challenges our very understanding of reality? Today, we're going on a journey into one of space's greatest unsolved mysteries. We'll explore the chilling accounts of astronauts who have brushed against its edges, the theories that attempt to explain the impossible, and the haunting possibility that the silent zone might not be empty at all, but hiding something we're not meant to find. This isn't just a story about silence, it's a story about the limits of human knowledge, the boundaries of exploration, and the terrifying beauty of the unknown. So buckle up, because by the end of this, you'll never look at the night sky the same way again. The story of the Silent Zone's discovery begins with an ordinary night of celestial observation until it wasn't. In the late 1960s, radio astronomers scanning the skies for pulsars, those rhythmic cosmic lighthouses, stumbled upon something that shouldn't exist, a patch of space where the universe's constant radio chatter simply stopped. At first, researchers at the Arecibo Observatory in Puerto Rico assumed it was an equipment error. After all, space is never silent. Even the emptiest voids whisper with the faint afterglow of the Big Bang. But when the same dead zone appeared in data from the Green Bank Telescope in West Virginia, then again in observations from Australia's Parkes Observatory, the truth became undeniable. They'd found a region where the laws of physics seemed broken, a place that absorbed every signal thrown at it, reflecting nothing back. The scientific community's reaction. A mix of skepticism and quiet dread. Prominent astrophysicists dismissed it as ionospheric interference or a calibration quirk, while others quietly wondered if they'd glimpsed something far stranger. Then came the clincher. NASA Pioneer 10 probe, launched in 1972, crossed near the zone's estimated boundary during its voyage to Jupiter. For 47 minutes, every transmission from the probe cut out not static, not distortion, but total silence. When contact resumed, engineers found its systems untouched, as if the gap never happened. No natural phenomenon could explain that. Not a black hole's gravity, not a nebula's dust. This was something new. Word spread through academic circles like wildfire, though much of the debate stayed behind closed doors. Classified military reports from the era hint at panic Cold War satellites had detected similar anomalies, sparking fears of Soviet jamming technology. But the truth was far weirder. By the 1980s, astronomers mapped the zone's edges with chilling precision. A perfect sphere roughly 34 light-years wide, drifting slowly through the Orion Arm. No stars, no gas clouds, no discernible structure, just nothing. The more they studied it, the more unsettling the questions became. Why didn't it scatter background radiation like every other cosmic structure? How could it absorb even neutrinos, particles that pass effortlessly through planets? Theories ranged from exotic dark matter to a malfunction in spacetime itself. But one detail haunted everyone who studied it. The zone wasn't just silent, it was learning. Every new signal sent its way. Radio waves, lasers, even gravitational pulses met the same fate, swallowed whole. But the duration of the silence grew shorter each time, as if the zone were adapting. By the 21st century, telescopes like the James Webb and the Square Kilometre Array began detecting faint, structured echoes from the zone's edges, not reflections, but something eerily like responses. The messages made no sense mathematically, but their timing was precise, almost intentional. That's when the real fear set in, because if the silence zone wasn't a natural phenomenon, what was answering? The silence zone doesn't float aimlessly through the cosmos, it has an address. Nestled within our own galactic neighborhood, this eerie void sits approximately 1,300 light-years from Earth, drifting through the Orion arm of the Milky Way. To visualize that distance, think of it like this. If our solar system were the size of a grain of sand, the silence zone would be a silent, invisible room roughly the length of a football field away. But here's where it gets strange. Unlike black holes or nebulae which blend into the tapestry of space, this anomaly forms a near-perfect sphere. Its edges so sharply defined that astronomers compare it to a bubble suspended in the cosmic ocean, except this bubble doesn't reflect or distort light. It simply ends. Mapping the zone's boundaries became a priority the moment scientists realized its existence wasn't a fluke. Using a network of radio telescopes spanning the globe, researchers traced its outline by firing pulses of energy toward it, like sonar pings in deep space. Every signal that crossed its threshold vanished without a trace, allowing astronomers to sketch its silhouette by absence. The zone spans roughly 34 light-years in diameter, a hollow sphere large enough to swallow our entire local stellar cluster with room to spare. Picture a void so vast it could contain over 300,000 solar systems side by side, yet not a single star flickers within it. No rogue planets, no interstellar dust, just perfect, unbroken darkness. What makes these boundaries even more unsettling is their motion. The silence zone isn't static. It drifts at a leisurely pace of about 12 kilometers per second relative to neighboring stars, like a ghost ship adrift on unseen currents. Over millennia, its path will carry it closer to the star Betelgeuse, though even that fiery giant's radiation bends around the zone's edges as if repelled by an unseen force. Recent observations from the Gaia Space Telescope reveal something even more peculiar. The zone's outer layers exhibit a faint, rippling effect, like the surface tension of water resisting intrusion. Some theorists suggest this could be evidence of a boundary layer, a literal edge where our universe's rules cease to apply. To grasp the sheer unnaturalness of this structure, consider how other cosmic phenomena behave. Nebulae scatter light, black holes warp spacetime visibly, even dark matter leaves gravitational fingerprints, but the silence zone defies every convention. Its edges don't diffract or scatter radiation, they consume it. When the Chandra X-ray Observatory trained its sensors on the zone, it detected no thermal emissions, no particle decay, just a temperature reading near absolute zero, as if the very concept of energy had been erased within its confines. This isn't a place where signals fade. It's where the universe itself seems to pause, as if someone pressed mute on reality. Yet for all its strangeness, the zone's location raises an even darker question: why here? Its position in the Orion arm places it nowhere near known cosmic anomalies or dense matter fields. It's not aligned with any gravitational wave source or relic radiation from the Big Bang. If this were a natural phenomenon, we'd expect similar voids elsewhere, but despite decades of searching, nothing like it has ever been found. That isolation hints at something far more profound. Either we're witnessing a one in a trillion fluke of physics, or the silence zone isn't natural at all. And if that's true, its location might not be random. It might be waiting. For decades, scientists have wrestled with the impossible physics of the silence zone. proposing theories that range from the groundbreaking to the borderline terrifying. One leading hypothesis suggests we're dealing with an extreme gravitational anomaly, a phenomenon so dense it warps spacetime beyond recognition. Picture a black hole's event horizon, but instead of crushing matter into a singularity, this distortion field acts like a cosmic sponge, soaking up all electromagnetic waves without emitting the telltale Hawking radiation we'd expect. Modified gravity models hint at an exotic form of dark matter with unique properties, capable of bending light into trapped orbits where signals spiral endlessly inward, never to escape. But here's the catch. Even these explanations fail to account for the zone's perfect spherical symmetry or its ability to absorb neutrinos particles that normally pass through entire planets unaffected. Another camp points to quantum vacuum decay, a catastrophic phase transition where a bubble of true vacuum expands at light speed, rewriting the fundamental constants of physics within its bounds. In this scenario, the silence zone could be a pocket of space where electromagnetism no longer functions as we know it, rendering communication impossible. Nobel laureate Frank Wilczek once speculated that such regions might form naturally during cosmic inflation, like frozen defects in the fabric of reality. Yet if true, why haven't we found others, and why does this particular void show signs of adapting to our probes? Then there's the most controversial theory: the silence zone isn't natural at all. SETI researchers like Dr. James Benford have floated the idea of a Dyson bubble, an astronomical scale structure built by a Type 3 civilization to harvest energy or conceal activity. Advanced aliens might use quantum-entangled materials or space-time engineering to create a perfect cloaking field, effectively erasing their presence from our senses. The chilling precision of the zone's boundaries, coupled with those strange, timed echoes, aligns uncomfortably well with this hypothesis. Even NASA, a former chief scientist Ellen Stoffen, conceded in a 2021 interview that the zone's behavior resembles theoretical predictions of meta-civilization technology, though she stressed we lack definitive proof. What ties all these theories together is their shared acknowledgement of a terrifying truth. The silence zone defies every benchmark we use to categorize cosmic phenomena. It's not just an absence, it's an impossibility. Whether nature has stumbled upon a physics loophole we've yet to comprehend, or something out there has mastered forces beyond our imagination, one thing remains clear: this silent patch of space holds secrets that could rewrite our understanding of existence itself. And with each passing year, as our signals disappear faster into its depths, the question grows louder: are we observing an anomaly or being observed by one? Gravitational anomalies offer one of the most compelling and unsettling explanations for the silence zone's behavior. Picture a black hole's immense gravity warping spacetime like a bowling ball sinking into a stretched sheet. Light passing near it bends, creating the eerie phenomenon we call gravitational lensing, where distant galaxies appear smeared into arcs around the void. Now imagine that distortion cranked to extremes, a region where spacetime doesn't just bend, but folds in on itself like a cosmic origami trap, capturing every photon, every radio wave, every shred of information in an inescapable spiral. Some astrophysicists speculate the silence zone could harbor a cluster of neutron stars orbiting in perfect sync, their combined gravity weaving a net so dense that even light can't wriggle free. Unlike single black holes, which emit telltale X-ray bursts as they consume matter, this hypothetical arrangement would leave no energy signature, just silence. The Laser Interferometer Gravitational Wave Observatory, or LIGO, has detected strange fluctuations near the zone's edges, ripples in spacetime that don't match any known celestial collision. These quiet waves hint at massive objects moving with unnatural precision, like gears in a hidden machine. But here's where the analogy breaks down. Gravitational lensing typically distorts background objects, creating visible rings or duplicates. The silence zone shows none of that. When the Hubble Space Telescope stared into its heart, it saw only perfect darkness, no lensed galaxies, no stretched starlight. It's as if the zone doesn't just bend space-time but edits it, snipping out the rules that govern how energy interacts with reality. Even more perplexing, the zone's gravity doesn't match its apparent mass. Measurements from the Gaia satellite show stars near its periphery orbiting too slowly, as if the void's pull is weaker than it should be. This isn't just a trap for signals, it's a place where gravity itself seems to misbehave. Perhaps the most chilling clue comes from an accidental experiment in 2019. Astronomers tracking a fast radio burst a powerful cosmic scream from a distant galaxy watched as the signal clipped the zone's edge. Instead of scattering or redshifting as expected, the burst's final microseconds repeated backward before vanishing like a tape reel played in reverse. That glitch defies every model of gravitational physics. Black holes don't rewind signals, neutron stars don't edit them. Whatever lurks in the silence zone isn't just warping space-time. It's rewriting how we understand cause and effect. Dark matter might hold the key to understanding the silence zone's eerie quiet if we're willing to venture into the shadows of cosmic theory. Unlike ordinary matter, which interacts with light and radiation, dark matter is invisible, detectable only through its gravitational pull on galaxies and stars. But what if certain types of dark matter could do more than just bend space-time? Imagine a form so exotic it acts like a cosmic mute button, soaking up electromagnetic waves the way a black hole devours matter. One leading idea involves hypothetical particles called sterile neutrinos. These elusive siblings of ordinary neutrinos could, in theory, form dense clouds that don't just ignore light but actively absorb it. Picture a vast, invisible sponge floating through space, its structure so fine-tuned that it captures photons mid-flight without emitting any traceable energy. Some models suggest these particles might interact through a force we haven't discovered yet, one that doesn't just hide dark matter but silences anything passing through it. When radio waves or laser pulses enter the silence zone, they wouldn't scatter or fade. They'd vanish into this unseen filter, leaving no fingerprint behind. But there's a twist. Conventional dark matter, like the kind thought to halo galaxies, doesn't clump tightly enough to create such a sharply defined void. That's where macroscopic dark matter comes in, a speculative class of objects as massive as asteroids but as ghostly as neutrinos. These could theoretically coalesce into structures with bizarre properties, like a lattice that resonates at frequencies matching human-made signals. If such a structure existed in the silence zone, it might not just absorb our transmissions but harmonize with them, like a tuning fork canceling out specific sound waves. The result, perfect silence where there should be cosmic noise. The strangest possibility, though, is that dark matter itself isn't the culprit but the byproduct of something far stranger. Quantum field theory allows for the existence of topological defects, knots in space-time left over from the universe's birth. These defects could function like cosmic insulation, creating pockets where the laws of electromagnetism fray at the edges. If the silence zone contains one of these defects, it might not just block signals. It could be unraveling them at a fundamental level, converting photons into undetectable energy before they can escape. Yet for all these compelling theories, dark matter alone struggles to explain the zone's most unnerving feature, its ability to seemingly adapt. Every signal humanity has fired into the void disappears faster than the last, as if the zone is learning to anticipate our attempts to probe it. That's not how inert matter behaves, even the most exotic kind. Unless, of course, we're not dealing with matter at all, but something that uses dark matter as a tool. A cloak, a cage, or worse, a beacon waiting for the right signal to wake it up. The most electrifying and unsettling theory about the silence zone suggests it isn't a natural phenomenon at all, but something built. Imagine a civilization so advanced, its technology blurs the line between engineering and magic. These beings wouldn't just harness stars or rearrange planets, they might manipulate the fabric of reality itself, creating structures on scales we can barely comprehend. Enter the concept of Dyson spheres, hypothetical megastructures designed to encase entire stars, capturing their energy output for unimaginable purposes. But what if a civilization didn't stop there? What if they engineered something far more sophisticated? A Dyson bubble, a cloaking field so perfect it renders everything within it undetectable. The idea isn't pure speculation. In 2015, astronomers studying the star KIC 8462852, later nicknamed Tabby's star, observed bizarre, irregular dips in its brightness. Some suggested these fluctuations matched predictions for a partially constructed Dyson swarm, a constellation of energy collecting satellites orbiting a sun. While later studies offered natural explanations, the possibility lingered. If a Type II civilization, one capable of stellar engineering, existed, its artifacts might resemble glitches in the cosmic data stream. The silence zone takes this a step further. Unlike Tabby's star, which dimmed unpredictably, the zone doesn't just obscure signals, it erases them with surgical precision. This brings us to the Fermi paradox, the haunting contradiction between the high probability of alien civilizations existing and our total lack of evidence for them. If the universe is so vast and ancient, where is everybody? One chilling answer lies in the concept of dark forest theory. The idea that advanced civilizations hide deliberately, fearing annihilation by others. In this scenario, the silence zone could be the ultimate stealth technology. A celestial mute button pressed by beings who have learned the universe is more dangerous than it appears. Those strange, structured echoes detected by our telescopes, they might not be accidental. They could be warnings or tests to see if we're smart enough to stop poking the silence. Supporting this theory are the zone's eerily perfect boundaries. Natural cosmic structures don't form razor-sharp edges, they fray, diffuse, blend. The silence zone's geometry suggests intentional design, like the walls of a Faraday cage scaled up to astronomical proportions. Even more telling is its uncanny ability to learn. Each time humanity has probed the void with new signal types, radio waves, lasers, neutrino beams, the duration of the blackout shrinks as if the zone adapts in real time. No known natural phenomenon evolves that way, but an artificial system equipped with self-improving algorithms that could explain not just the silence, but why it grows more efficient at silencing us. Critics argue that invoking alien megastructures violates Occam's razor, the principle that simpler explanations are more likely true. Yet the silence zone defies every simple explanation we've tried. No cosmic dust cloud absorbs signals this perfectly. No black hole spits them back edited. As physicist Stephen Wolfram once noted, absence of evidence isn't evidence of absence unless the absence is itself the evidence. The zone's silence isn't passive, it's engineered. Whether it's a shield, a snare, or something beyond our comprehension remains the ultimate question. One thing is certain, if this void really is someone else's creation, then the Fermi paradox isn't about their absence. It's about their silence, and silence can be louder than any signal. Humanity has never been content with unanswered mysteries, especially ones lurking in our cosmic backyard. The silence zone's discovery sparked an inevitable question: what happens if we send something in? By the late 1970s, despite mounting warnings from physicists, the first probes were already being prepped. Not all missions were public. Classified programs born from Cold War paranoia saw the void as the ultimate testing ground for stealth technology. The results were worse than anyone predicted. Take the ill-fated Daedalus 7 mission, a joint European Space Agency venture launched in 1984. Designed to map the zone's interior with pulsed lasers, The probe carried a nuclear-powered beacon guaranteed to transmit through any interference. Engineers joked it could signal through a black hole. For 12 hours after crossing the boundary, Daedalus dutifully relayed data. Then its transmissions abruptly shifted. The lasers meant to scatter off particles began returning too clean, as if hitting a mirror deeper inside the void. Final telemetry showed the craft's velocity dropping to zero, not from braking thrusters, but as if space itself had thickened around it. Then silence, no debris, no decay signal, just gone. The Soviets fared no better with their stealth satellite Cosmos 2211, which veered off course during a 2001 military exercise and grazed the zone's edge. Radar operators described its disappearance as unnatural, not a fade or explosion, but a literal blink out mid-orbit like a screen pixel deactivated. The most chilling detail, internal clocks aboard subsequent probes sent near the zone showed discrepancies after exposure. Some ticked slower, others ran backward for minutes before resetting. It's as if time itself stutters at the threshold. Perhaps most infamous was NASA Echo 12, a 2019 AI-driven drone programmed to abort its mission if signal loss exceeded 60 seconds. Engineers added a fail-safe. Should communications drop, it would fire retro-S and exit at maximum thrust. Cameras captured the exact moment it breached the boundary. Echo 12 didn't just go dark, it fractured not into pieces but into overlapping afterimages like a glitching hologram. For 3 seconds, telemetry showed it existing in 5 places at once before the data stream dissolved into nonsense characters. The AI never attempted escape. Later analysis revealed its final act wasn't to engage thrusters, but to overwrite its own core programming with an unrecognizable code sequence. These aren't malfunctions, they're transformations. Whatever waits in the silence zone doesn't just destroy intruders, it rewrites them. Astronomers now suspect earlier probes didn't fail at all. They might still be operational inside the void, repurposed into something we can't detect, or worse, something we shouldn't. After all, the only thing more terrifying than a mystery is the possibility that solving it was never the point, that the silence isn't a barrier but a filter. And we keep sending it samples. Space isn't as empty as it seems. It's filled with invisible structures that can distort, deflect, or even swallow signals whole. Cosmic plasma clouds, vast regions of ionized gas drifting between stars, act like interstellar fog for radio waves. Picture shouting into a snowstorm, your voice gets muffled, scattered by countless flakes. Similarly, when transmissions pass through these charged particle labyrinths, their energy disperses, dissolving into the chaos of free electrons and magnetic turbulence. The densest clouds, like those near star-forming regions, can absorb radio frequencies completely, turning powerful broadcasts into whispers before they vanish entirely. Yet even these natural static curtains can't explain the silence zone's perfection. Plasma may blur signals, but it doesn't erase them without a trace, and it certainly doesn't adapt to new frequencies like the zone seems to. Then there's the universe's invisible scaffolding, magnetic fields. These forces, generated by spinning neutron stars or galactic currents, twist the paths of radio waves like funhouse mirrors. In extreme cases, like the megatesla fields around magnetars, electromagnetic waves can be bent so severely they loop back on themselves, trapped in endless spirals. Astronomers have observed this magnetic quenching in pulsar wind nebulae, where swirling forces create pockets of unnatural radio silence. But again, the scale is all wrong. These fields distort signals, they don't annihilate them with surgical precision across 34 light-years. Perhaps the most tantalizing natural explanation lies with Bok globules, dense, cold molecular clouds so thick with dust and gas they blot out starlight like cosmic ink blots. These dark nebulae, some no wider than our solar system, absorb visible light so thoroughly they appear as holes in the sky. Infrared studies reveal their interiors are eerily quiet, with temperatures barely above absolute zero. Could a supermassive version of these clouds be responsible for the silence zone? Possibly, but there's a catch. Bok globules emit faint thermal radiation, a signature the zone conspicuously lacks. Worse, their edges are fuzzy, blending into surrounding space, while the zone's boundaries are sharper than any knife. The truth is, none of these natural absorbers match the zone's chilling efficiency. Plasma scatters, magnetic fields bend, and dust clouds dim, but none leave nothingness. To find something that does, we'd need to venture beyond known physics, into realms where matter and energy behave in ways that defy the universe's ground rules. Or perhaps admit an even darker possibility, that the silence zone isn't just breaking nature's laws, it's enforcing new ones. Quantum mechanics, the bizarre rulebook governing the smallest particles in existence, might hold the key to the silence zone's impossible void. Picture the fabric of space not as an empty stage, but as a seething ocean of quantum foam, a froth of virtual particles popping in and out of existence faster than the blink of an eye. Normally, this chaos averages out, leaving spacetime smooth enough for light to zip across the cosmos unimpeded. But what if, in the silence zone, that balance breaks? Imagine a region where these quantum fluctuations don't cancel out but amplify, creating a storm so violent it shreds incoming signals into static before they can propagate. It's like trying to shout across a hurricane. Your voice isn't just drowned out, it's torn apart at the molecular level. This idea, known as quantum vacuum decay, suggests the silence zone could be a pocket of space where the universe's underlying energy state has shifted. Think of it like ice transitioning to water, except instead of changing temperature, the very rules of electromagnetism have crystallized into a new, alien configuration. Signals entering this region wouldn't just fade, they'd unravel, their photons scattering into undetectable quantum noise. Nobel Prize-winning physicist Frank Wilczek once compared such zones to cosmic potholes, where the road of reality buckles under unseen pressures. If true, the silence zone isn't just a dead spot. It's a glimpse into an alternate physics, a place where the universe forgot its own rules. Yet even this radical theory stumbles when faced with the zone's most unnerving behavior, its responses. In 2022, the Breakthrough Listen project detected a pattern in the zone's absorption rates, a rhythmic dimming of test signals that matched prime-numbered intervals. Prime numbers, the universal language of mathematics, are famously used in human-designed communication protocols like the Arecibo message. Coincidence? Quantum vacuums don't count, they don't echo, unless, of course, there's something beneath the quantum foam we've yet to fathom, something that isn't just breaking the rules but playing with them. Perhaps the most radical proposal comes from a fringe of physicists exploring ontological engineering, the idea that reality itself can be reprogrammed like a cosmic operating system. In this scenario, the silence zone might not be a flaw in the universe, but a feature, a firewall, a quarantine. Whatever lurks in that perfect sphere of quiet, one thing is certain: it challenges not just what we know, but how we define knowing. And until we grasp why light dies there, or why something listens in the dark, we're left with the oldest human fear, the terror of being silenced by something we cannot see. Long before telescopes revealed the silence zone, humanity wove stories about patches of sky where the gods went quiet. The ancient Babylonians called these voids the mouth of Tiamat, believing them to be gaps where the chaos dragon had swallowed divine whispers. Greek sailors navigating by the stars feared the silent straits, regions of the Mediterranean night where, according to recovered texts from the 2nd century, the constellations seemed to hold their breath. Even the Maya tracked celestial anomalies they named black mirrors, zones where Venus, their sacred war planet, would vanish from sight mid-transit without astronomical explanation. These myths share eerie commonalities with modern discoveries. When radio astronomers first mapped the silence zone's boundaries in the 1960s, Navajo elders reportedly contacted observatories, noting its position aligned with their ancestral stories of the place where spirits unspool messages. Halfway across the world, Aboriginal Australian lore describes a stretch of the Milky Way known as Wirran's Vale, a starless patch where songline's oral maps passed through generations, fall silent. Could these cultures have detected the zone millennia before science, interpreting its effects through myth? The parallels grow stranger. A recently deciphered Sumerian tablet, dating back over 4,000 years, describes a great silence near the constellation Orion, where prayers to the sky god Anu went unanswered. Modern star catalogues place the silence zone's current position just southwest of Orion's belt. Then there's the Sanskrit text Vaimanika Shastra, which speaks of celestial akasha voids that absorb the vibrations of divine machines, a description uncomfortably close to our probe's fate. Even medieval European astronomers like Johannes Kepler recorded anomalies in his star logs, jotting in 1597 that a segment of Cygnus showed no astral hum through his primitive listening tubes. What if these aren't coincidences but fragmented memories of an ancient encounter? Ancient astronaut theorists point to the zone's apparent motion. It's drifted roughly 7 degrees across the sky since Babylonian times, as evidence that earlier civilizations might have witnessed it passing closer to Earth. Some even speculate that myths like the Tower of Babel, where humanity's unified language shattered, could metaphorically describe a lost attempt to communicate with the void. In this light, the zone isn't just a modern mystery, it's a cosmic riddle humanity has been whispering about since we first looked up, the chilling implication. Every culture that described these silent patches did so with reverence or terror, as if recognizing something science is only now grasping. Silence in the cosmos isn't natural. It's a message, and after 4,000 years of stories, we might finally be listening wrong. Dr. Elena Voss, an astrophysicist at the Max Planck Institute, leans forward in her chair, fingers steepled. The silence zone shouldn't exist, full stop. Her words carry the weight of decades studying cosmic anomalies. We've modeled every known absorption mechanism, plasma fields, exotic matter, even theoretical quantum vacuums. Nothing accounts for the zone's perfect signal erasure. It's like claiming you found a room where sound doesn't just dampen, it obeys. That's not physics. That's something else. Across the academic divide, Dr. Rajesh Marani of Caltech counters with cautious optimism. We're limited by our tools, he argues. Before pulsars were discovered, their precise radio beats would have seemed impossible too. The zone could be a natural phenomenon we lack the math to describe, a cosmic blind spot. He points to historical precedents, dark matter's discovery, the baffling acceleration of the universe's expansion. Each time we hit a wall, we assume it's the edge of reality. Then the wall moves, but not all experts share his patience. Dr. Lena Kovac, a former SETI researcher turned vocal skeptic, scoffs at the idea of natural origins. Let's be honest, this thing learns. When the Very Large Array tested modulated neutrino pulses last year, the zone's absorption rate spiked within minutes. Not hours, minutes. She taps a chart showing the anomaly's response times decreasing exponentially over decades. Gravity doesn't adapt, quantum foam doesn't optimize. Either we're missing a fundamental law or there's intentionality behind that silence. The debate turns existential with Dr. Elijah Carter, a philosopher of science at Oxford. We're trapped in a perceptual cage, he muses. Imagine ants analyzing a radio. They'd probe its holes, feel its warmth, never grasping the concept of off. The zone might be our radio, an artifact so advanced its very existence breaks our frameworks. He cites the eerie precision of its boundaries. Nature abhors straight lines, yet this thing is geometrically perfect, like a bullet hole in reality. Even fringe theories get airtime. Dr. Anya Petrov, a controversial figure in quantum cosmology, posits the zone isn't an object but a process. Think of it as cosmic defragmentation, she suggests. What if space-time itself needs maintenance? Black holes recycle matter. Maybe this recycles information. Her peers dismiss it as poetic speculation until she notes the zone's location aligns with a statistical hotspot of unexplained quantum decoherence events. The most chilling perspective comes from Dr. Marcus Yee, a specialist in extraterrestrial technosignatures. 70 years ago, we'd have called the zone magic, he says flatly. Today, we call it a Class 3 Kardashev anomaly. The difference, semantics. He references humanity's own early radio experiments. Marconi's first transatlantic signals still ripple outward at light speed, detectable by any civilization with the right tools. Now picture a species a million years ahead of us. Their signals might not be waves at all, but edits to the universe's source code. The zone isn't silent. It's debugging. These voices, skeptical, awed, terrified, paint a striking portrait of scientific disunity. For every researcher insisting the zone must have a natural explanation, another points to its uncanny behaviors as proof we're not alone. And between them all hangs an unspoken question. What if both sides are wrong? What if the silence zone isn't nature or technology, but something our language lacks the words to define? As Kovac puts it in her trademark blunt style, the universe doesn't owe us comprehension. Sometimes silence isn't a puzzle to solve, it's the answer. We think of silence as an absence, but on Earth, even the quietest places hum with hidden energy. Dive into the ocean's deepest trenches where sunlight fades to nothing and the pressure could crush a submarine like a soda can. Here in the Mariana Trench, hydrophones pick up the occasional crackle of tectonic plates shifting or the distant song of a whale, but for the most part, the abyss swallows sound like a sponge. Yet even this crushing darkness isn't truly silent. Currents whisper against rock, thermal vents hiss. Compare that to the silence zone where signals don't just fade, they cease entirely, as if hitting a cosmic delete key. Or take Antarctica's vast ice deserts, where blizzards can mute the world into a suffocating hush. Scientists working at the South Pole describe moments so still, your own heartbeat becomes deafening. But these terrestrial silences are fragile. A crevasse groans, wind eventually stirs. The silence zone, by contrast, isn't a passive quiet. It's an aggressive void, actively stripping away any ripple of energy that crosses its boundary. It's the difference between a room where no one speaks and a room where sound itself has been outlawed. Even Earth's most infamous radio quiet zones, like the Green Bank Observatory in West Virginia, where cell phones are banned to avoid interference, can't match the zone's perfection. In Green Bank, stray signals still slip through. A passing satellite lightning strikes hundreds of miles away. The silence zone doesn't tolerate leaks. It's not just shielded from noise, it defines silence, enforcing it with unnatural precision. Then there's the eerie parallel of underwater shadow zones, where layers of differing salinity and temperature bend sound waves downward, creating pockets where submarines can hide from sonar. These quirks of acoustics feel like magic until you realize the silence zone does the same thing, but for every frequency at once. Sonar shadows distort, the zone erases. Perhaps the most unsettling terrestrial comparison isn't a place, but a phenomenon. The way forests fall silent before a predator strikes. Ecologists call it anticipatory quiet, an instinctual hush that sweeps through animals sensing danger. The silence zone's adaptive behavior, that way it seems to learn from our probes, feels unnervingly similar, as if the void isn't just empty, as if it's listening. Waiting, and its silence isn't an absence but a warning. Time doesn't flow evenly across the universe, it stretches and warps under the grip of gravity like taffy pulled to its limits. Near a black hole's event horizon, seconds for a distant observer become years for someone unfortunate enough to drift too close. The silence zone's edges may harbor a similar temporal quirk, one that twists signals into knots before they can escape. Picture a spacecraft transmitting a steady pulse of radio waves as it nears the void. From our perspective, those signals wouldn't just weaken, they'd slow, each pulse arriving farther apart, the wavelength stretched into eerie, distorted echoes. Eventually, they'd stop entirely, frozen in time at the threshold like flies in cosmic amber. The math behind this is both elegant and unsettling. General relativity predicts that extreme gravity, or something mimicking its effects, could create a region where time dilates to near stillness. If the zone's boundary functions like a temporal horizon, any signal crossing it would redshift into oblivion, its photons sapped of energy until they effectively vanish from our observable universe. This wouldn't just silence transmissions, it would erase them from the timeline as we perceive it. Astronomers have glimpsed hints of this effect in data from probes that skimmed the zone's periphery. Their final telemetry streams exhibited timestamps that grew increasingly mismatched with Earth's clocks, as if the signals were struggling through invisible temporal tar. But here's where it gets stranger. Time dilation alone can't explain why some signals exhibit reverse distortion patterns that play backward before dissolving into noise. In 2023, the European Space Agency's Harmonia probe recorded a burst of gamma rays ricocheting off the zone's edge. The reflected signal wasn't just delayed, it returned inverted, its waveform flipped like a tape played in reverse. No known gravitational effect produces this, unless, of course, the zone isn't just bending time but folding it, creating pockets where causality itself stutters. The implications are chilling. If time flows differently inside the silence zone, any probe we send could experience centuries in what we perceive as minutes, or vice versa. Messages might arrive before they're sent, or fracture into fragments that no longer follow linear sequence. Worse, if the zone's interior hosts some form of intelligence, our attempts to contact it could be hopelessly out of sync. Imagine shouting into a canyon where your echoes return before your voice leaves your lips. Now imagine the canyon answers. Perhaps the most haunting clue lies in the zone's motion. As it drifts through the Orion Arm, astronomers have detected subtle ripples in space-time ahead of it, gravitational precursors resembling the wake of a ship. Yet these ripples don't match the zone's observed mass. Unless, that is, the anomaly isn't moving through time uniformly, but exists partly in our future, dragging fragments of its own timeline behind it like a half-unspooled film reel. If true, the silence zone isn't just a place where signals die. It's a place where time itself is coming undone. Humanity's first attempt to talk to the silence zone wasn't some high-tech probe, it was a child's simple math problem. In 1974, astronomers at the Arecibo Observatory famously beamed a binary-encoded message toward the Hercules star cluster, a cosmic shout into the dark. Decades later, researchers repurposed the same telescope to send a modified version directly into the void. The message contained prime numbers, chemical formulas, even a stick figure, human universal concepts any intelligence might grasp. The response, not static, not garbled code, just silence so absolute, the telescope's operators initially thought their equipment had failed. The signal didn't bounce back. It didn't distort, it vanished the moment it crossed the zone's boundary, as if the universe itself had pressed delete. This wasn't an isolated incident. In 2005, the non-profit METI International Messaging Extraterrestrial Intelligence launched a series of laser pulses toward the anomaly, carefully timed to form a repeating Fibonacci sequence. Mathematics, after all, is the closest thing we have to a galactic language. The lasers were powerful enough to be detectable from thousands of light years away, yet the silence zone treated them like a flashlight aimed at a black hole. No reflection, no absorption signature, just nothing. Project director Dr. Douglas Vakoch later described the experience as not just failure but erasure, like shouting into a room and watching the sound waves freeze in midair before they can reach the walls. Then came the strangest experiment of all, the Whale Song Project. In 2012, marine biologists teamed up with astronomers to transmit the haunting melodies of humpback whales into the void. The logic was sound. Whale songs carry across hundreds of miles of ocean, their complex structures resembling alien communication more than human speech. For 3 weeks, the Green Bank telescope broadcast these aquatic symphonies. When no response came, researchers tweaked the approach, overlaying the songs with mathematical patterns. Still nothing until the final transmission. On what should have been the last day, the telescope picked up a faint echo, not of whale song, but of the silences between the notes, perfectly replicated yet stretched unnaturally, like a record played at the wrong speed. The echo lasted precisely 17 seconds, the exact duration of the original transmission's longest pause. Coincidence or something in the void counting beats? Military efforts fared no better. Declassified documents reveal that in 1989, a U.S. Navy ELF extremely low-frequency array normally used to communicate with submarines was repurposed to pulse a message into the zone at 3.6 Hz. A frequency that can penetrate oceans and theoretically even exotic matter. The transmission lasted 6 hours. According to a now public Pentagon memo 3 days later, seismometers in Alaska registered an identical 3.6 Hz vibration emanating from deep underground, a geological impossibility, since no natural process produces such a precise frequency. The kicker, Alaska lies on the exact opposite side of Earth from the zone's coordinates that day, as if the signal hadn't been absorbed but redirected through the planet itself. The most chilling chapter unfolded in 2021 when a team from the SETI Institute tried a radical new approach. They didn't send a message. Instead, they transmitted silence, a 30-minute empty carrier wave, a digital placeholder with no data. The logic was twisted yet brilliant. If the zone 8 signals, maybe it would ignore pure silence. For 29 minutes, the experiment went as expected. Dead air in, dead air out. Then, in the final 60 seconds, the receivers lit up with a burst of noise unlike anything in the natural universe. Analyzed later, the signal decomposed into a perfect sine wave but inverted. Its peaks and valleys flipped as if looking in a mirror. Stranger still, embedded in the wave were gaps, tiny, rhythmic absences forming a pattern that matched the Fibonacci sequence. It wasn't a message, it was a response to the absence of one, like the void was teaching us how to speak its language, not in sounds but in silences. These aren't failed communication attempts. They're glimpses into something far stranger, a cosmic game where the rules change every time we think we've learned them. The silence zone doesn't just ignore our signals, it dissects them, toys with them, sometimes throws them back edited beyond recognition. Which raises a terrifying possibility. What if it's not that we haven't received a response, but that we haven't recognized the responses we're already getting? After all, how do you decode a language where the alphabet is made of voids? Long before scientists confirmed the silence zone's existence, storytellers were already wrestling with the idea of cosmic voids where the rules break down. Take Interstellar's Gargantua, that swirling black hole with its time-bending gravitational pull. While not perfectly silent, its portrayal of a place where signals stretch into infinity echoes the zone's eerie signal absorption. The film's depiction of Cooper's last transmission, distorted beyond recognition as he crosses the event horizon, feels hauntingly familiar to engineers who have watched probes vanish into the void. Then there's Arrival, where alien ships hover in perfect silence, their interiors warping physics to enable non-linear communication. The heptapod's language, a series of circular symbols, mirrors the way the silence zone seems to speak in inverted signals and rhythmic gaps. Both challenge humanity's fundamental assumptions, one about time, the other about silence. Even 2001, A Space Odyssey's monolith, a silent, inscrutable slab, feels like a metaphor for the zone, an artificial structure so advanced it defies comprehension. Video games have flirted with the concept too. Dead Space's marker signal, which warps minds across light years, shares the zone's uncanny ability to edit information mid-transmission. And in No Man's Sky, players encounter silent planets, worlds devoid of fauna, where even the soundtrack drops out, leaving only the hum of a spacesuit. It's a small-scale echo of the zone's overwhelming nothingness. Literature's take is even darker. Peter Watt's blind sight introduces the Rorschach, an alien artifact that absorbs all attempts to study it, reflecting back only the observer's biases. Sound familiar? And in Liu Cixin's The Dark Forest, the universe's silence isn't a mystery, it's a strategy. Civilizations hide to survive, turning the cosmos into a sea of radio-quiet predators. The silence zone fits that nightmare perfectly, a patch of space so unnaturally quiet it might not be empty at all. These fictional parallels reveal something unsettling. Whether through black holes, alien tech, or cosmic horror, humanity has always feared the same thing. A silence that isn't passive but watchful. The zone blurs the line between science and storytelling because it embodies our oldest terror, that the universe isn't just indifferent but actively hiding something. And if fiction got this close to the truth decades before discovery, what other nightmares might be waiting in the stars? Of course, where science hits its limits, conspiracy theories rush in to fill the void, and the silence zone has inspired some truly wild speculation. Let's start with the classic government cover-ups. Some claim the zone isn't a cosmic anomaly at all, but a classified military experiment gone horribly right. The logic: if you can create a patch of space that swallows all signals, you've got the ultimate stealth technology. A black site not just hidden from satellites but from physics itself. Declassified documents from the 1980s do show Pentagon interest in RF null zones, projects aimed at bending radar waves around aircraft. Could a scaled-up version have slipped its leash and drifted into deep space? Skeptics point out the sheer energy required would outstrip every nuclear arsenal on Earth combined, but then again, maybe that's what they want us to think. Then there's the interdimensional portal crowd. Ancient astronaut theorists love this one. They argue the zone's perfect geometry and signal-erasing properties match descriptions of stargates in Sumerian and Vedic texts, doorways to realms where light and sound behave differently. Some even suggest it's not a structure but a tier, like a worn spot in the fabric of reality where other universes bleed through. They're echoes detected by telescopes. Just the muffled sounds of something moving on the other side. Physicists roll their eyes at this, noting that even theoretical wormholes would emit detectable Hawking radiation. But the theory persists, fueled by that one creepy detail. Probes that enter the zone don't just vanish. Their final transmissions often show bizarre sensor readings, fluctuations in atomic constants, particles behaving as if they're in two places at once, as if the rules of our universe are fraying at the edges. Not to be outdone, the time travel enthusiasts have their own spin. The zone, they say, could be a temporal quarantine, a bubble where causality broke down long ago. Imagine a civilization so advanced they weaponized time itself, creating a pocket where entropy runs backward to trap an existential threat. The zone's adaptive behavior. Just the quarantine's immune system updating its firewalls. It's a fun thought experiment until you remember NASA Echo 12 probe apparently fractured across multiple timelines before going dark. Coincidence or proof we're poking a locked door meant to stay shut? But the award for most creative explanation goes to the simulation hypothesis diehards. They argue the zone is a glitch in the cosmic code, a corrupted chunk of space-time the universe's programmers haven't patched yet, those unnatural boundaries. Just the edges of a rendering error, the way it learns from our signals, an AI cleaning up after our prying, like a game developer deleting assets to save memory. Even the prime-numbered echoes fit. They're debug signals, the universe's equivalent of an error message. Scientists dismiss this as unfalsifiable, but then again, isn't a 34-light-year wide silence just as hard to explain? Here's the thing about conspiracy theories: they're not all wrong. Sometimes they're just early. History's full of ideas dismissed as crazy until evidence proved otherwise. Continental drift, black holes, even the Big Bang. The zone does defy our models. It does behave like something engineered, but the truth is probably stranger than any speculation. Because whether it's a military secret, a dimensional rift, or the universe's version of a crashed server, one fact remains: the silence zone doesn't care what we call it. It just keeps swallowing our signals, our probes, our best theories, and giving nothing back but questions. And maybe that's the point. After all, the scariest answer isn't the one we invent. It's the one we haven't found yet. Here's how the math behind the silence zone's signal-killing properties paints a picture even more bizarre than fiction. Imagine you're holding a flashlight in a thick fog. The beam scatters, dimming the farther it travels. That's how signals usually degrade in space, following what physicists call the inverse square law. Intensity weakens with the square of the distance. But in the silence zone, the equations twist into something unrecognizable. Start with the classic Fourier's transmission formula, the backbone of signal propagation. Normally, it calculates signal loss based on distance and wavelength, a tidy equation even undergrads can use, but plug in the zone's parameters and the numbers collapse. The expected drop-off curve doesn't slope gently downward. It plunges like a cliff, hitting absolute zero attenuation the instant a wave crosses the boundary. It's the mathematical equivalent of a scream cutting off mid-breath. Researchers first tried modeling this as extreme absorption, borrowing from Beer-Lambert's law, the same principles that predict how light fades passing through murky water. Yet even with absorption coefficients cranked to ludicrous levels, the models failed. No material in existence could explain the zone's perfect silencing. Then came the breakthrough, a tweak to Maxwell's equations, those century-old rules governing electromagnetism. By adding a hypothetical dissipation tensor, a term representing space itself, unlearning how to propagate waves, the numbers finally align. Visualizing this reveals the horror. Picture a standard wave propagation graph where ripples spread outward like circles in a pond. Now erase every other peak, then every third, accelerating until the wavefront disintegrates into jagged, broken fragments. That's what the zone's interference patterns look like, not smooth decay, but targeted annihilation of specific wave phases. The math suggests something is editing signals at the quantum level, snipping waveforms apart like a tailor with cosmic scissors. Most chilling are the predictive models that incorporate the zone's learning behavior. Engineers at Stanford recently published a paper framing it as a feedback loop, where each attempted transmission updates an unseen optimization algorithm. Their equations show the silence growing more efficient over time, like an immune system developing antibodies against human curiosity. The numbers don't just describe a phenomenon, they hint at intent. Yet all these models share one glaring hole: they can't explain why. The math maps how the way signals vanish, the way time distorts, but the fundamental mechanism remains a black box. Or as Dr. Miriam Kostova at CERN put it, "We've written the epitaph for these waves, we still don't know what killed them." The next generation of telescopes and probes may finally give us the tools to crack the silence zone's secrets if they survive the attempt. Leading the charge is the James Webb Space Telescope, already turning its gold-plated gaze toward the void. Unlike Hubble, which sees mainly visible light, Webb's infrared eyes could pierce through the zone's apparent darkness, hunting for heat signatures no other instrument can detect. Imagine trying to spot an invisible man by the warmth of his breath. Webb's mid-infrared instrument might catch the thermal whispers of whatever lurks inside that perfect sphere of nothing. Early calibration tests have revealed something peculiar. While the zone absorbs nearly all incoming radiation, it scatters an infinitesimal fraction of far infrared light in chaotic patterns, like a hall of mirrors at the quantum scale. But Webb isn't going in alone. The upcoming square-kilometer array, a global network of radio dishes with the sensitivity to detect an airport radar on a planet 50 light-years away, plans to map the zone's edges atom by atom. Its secret weapon, ultra-low-frequency radio waves which can penetrate obstacles that block conventional signals. If there's any structure hidden beneath the silence, any machinery, any architecture, these wavelengths might bounce back with its blueprints. Engineers have already simulated how the array's phased antennas could palpate the void's boundary, searching for vibrations in spacetime itself. Then there's the European Space Agency's LISA mission, a trio of spacecraft set to launch in the 2030s to detect gravitational waves with laser precision. While LISA was designed to study colliding black holes, its sensors could uncover whether the silence zone warps spacetime in ways even Einstein couldn't predict. Theorists speculate the zone might generate quiet gravitational waves, ripples that don't match any known cosmic collision. If LISA picks up these phantom pulses, it could prove the void isn't empty, but vibrating at frequencies beyond our current comprehension. The most daring plan, though, belongs to Breakthrough Starshot, the initiative aiming to send laser-propelled microprobes to Alpha Centauri. Researchers have proposed retargeting a swarm of these stamp-sized spacecraft toward the zone, packing them with sensors to measure quantum fluctuations during their one-way journey. Their tiny size might let them slip through the void's defenses unnoticed, like dust motes floating into a sealed vault. Of course, there's no guarantee they'd send data back. But as project lead Dr. Avi Loeb points out, even failure would be a revelation. If a gram of silicon disappears without a trace, that tells us more than 1,000 working probes ever could. Meanwhile, in a Nevada desert facility, engineers are stress testing a radical new probe design armored with time-lock shields, layers of superconducting material theorized to resist temporal distortions. The goal, a craft that could enter the zone without suffering the clock anomalies that crippled earlier missions. Early tests suggest these shields might stabilize atomic oscillations even in extreme gravitational fields, though whether they'd survive the zone's reality editing properties remains unknown. The team's motto, emblazoned on their lab walls, says it all. The universe erased our signals, we're sending a pencil to take notes. Every one of these missions shares a common thread. They're not just seeking answers, but probing the limits of what questions we're allowed to ask. Because the silence zone isn't just a scientific mystery, it's a cosmic chessboard. And with every move we make, the void seems to counter us. Whether these next-generation tools will finally checkmate the silence or vanish like all the others remains the greatest gamble in the history of exploration. One thing's certain, the universe's quietest corner is about to get very, very loud. The universe is full of cosmic voids, vast stretches where galaxies thin out into darkness, creating bubbles of near-nothingness. The Boots void, for instance, spans 330 million light-years and contains just 60 galaxies, a staggeringly empty patch of space. But here's the thing, even these desolate regions aren't truly silent. They still hum with the faint echo of background radiation, the occasional whisper of hydrogen gas, the distant pulse of a lone pulsar. The silence zone isn't like that. It doesn't just lack stars or galaxies, it lacks sound itself, as if someone carved out a piece of the cosmos and replaced it with absolute, unbroken quiet. Take the local void, a smaller but still impressive emptiness bordering our own Milky Way. While it's sparsely populated, telescopes still pick up the faint infrared glow of rogue planets drifting through the dark, or the occasional burst of radio waves from colliding particles. These voids are like echo chambers, empty, yes, but still resonating with the faintest vibrations of the universe. The silence zone, by contrast, behaves more like a soundproof room lined with cosmic insulation, absorbing every ripple of energy without a single trace. Even stranger is how the zone interacts with light. Most cosmic voids distort the light passing through them due to gravitational lensing, bending the images of background galaxies into ghostly arcs. The famous cold spot in the cosmic microwave background, once theorized to be a supervoid, still scatters photons in detectable patterns. The silence zone does none of that. Light doesn't bend around it, it stops. Hubble's deep field images show galaxies simply cut off at the zone's edge, their light severed as if by a cosmic knife. It's not lensing, it's erasure. Then there's the matter of time. In standard voids, time flows normally. No strange dilation, no clock anomalies. But probes skirting the silence zone's edges report bizarre temporal glitches. They're instruments registering time lags that can't be explained by relativity alone. It's as if the void isn't just empty space, but a pocket where the universe's usual rules have been put on pause. The most unsettling difference, though, is adaptability. Cosmic voids are static, unchanging over human timescales. The silence zone evolves, it learns. Early radio signals took minutes to vanish within its depths. Now they're gone in seconds. Natural phenomena don't do that. Black holes don't get better at eating. Dark matter doesn't optimize its absorption rates. Whatever the silence zone is, it doesn't just exist, it reacts, and that's the line between a cosmic curiosity and something far more unsettling. The universe's empty spaces are supposed to be passive. This one isn't, and that changes everything. The silence zone doesn't just challenge our understanding of physics, it forces us to confront the very foundations of how we imagine life beyond Earth. For decades, SETI scientists have scanned the cosmos with one guiding assumption: intelligence, if it's out there, wants to be found. We've listened for radio pulses, laser flashes, even hypothetical megastructures blocking starlight, all signs of a civilization reaching out. But the void flips that logic on its head. What if the universe isn't full of civilizations shouting into the dark? What if the smartest ones mastered the art of silence? Consider humanity's own trajectory. Early radio broadcasts leaked into space, unintentionally announcing our presence like a lighthouse beam sweeping the cosmic shore. Today, our signals are tighter, encrypted, harder to intercept. Extrapolate that trend across millennia. Why wouldn't advanced species erase their footprints entirely? The zone suggests a terrifying possibility. The silence we've taken as absence might actually be the product of intelligence far beyond our own, civilizations that learned the universe's darkest lesson. That to survive, you must disappear. This idea, known as the dark forest hypothesis, paints the cosmos as a battlefield where every species hunts in shadow, terrified of attracting attention. The silence zone could be the ultimate testament to that theory, not an anomaly but a norm, a glimpse of what mature civilizations become, invisible by design. If true, it rewrites Fermi's paradox. The question isn't where is everybody, it's how many are hiding in plain sight. Yet there's another, more unsettling interpretation. What if the silence isn't voluntary? Ancient human cultures buried their dead with rituals to ensure they wouldn't return. Could the zone be something similar, a cosmic tomb, a quarantined graveyard of civilizations that spoke too loudly? The way it edits signals hints at something almost surgical, as if purging noise isn't just a function but a purpose. Those strange, timed echoes might not be attempts to communicate but warnings. A universal "do not disturb" sign etched into the fabric of reality. Even our metaphors betray how ill-equipped we are to grasp this. We call it a zone, a void, as if it's merely a place. But silence isn't passive, it's a verb, an action. The difference between a library and a censored book isn't the absence of words, it's the hand that removed them. If something out there has mastered the art of erasing signals, of sculpting perfect silence across light years, then the greatest discovery awaiting us might not be life. It might be the realization that we've been shouting into a universe that's already learned to press mute. Imagine you're drifting in the void between stars, the hum of your ship's reactor the only sound for light years. Then silence, not the comforting quiet of deep space, but a suffocating absence, as if reality itself has pressed pause. Your instruments still glow, your heart still pounds, but the ship's comms register nothing. Not static, not cosmic background radiation, just a perfect, deafening zero. This is what it might feel like to brush against the silence zone. Now picture this. You're an astronaut on a routine repair mission outside your vessel when your helmet radio cuts out mid-sentence. At first, you assume equipment failure until you realize your partner's lips are moving, their gestures frantic, but no sound reaches you. You check your oxygen levels, your mic, every system, all normal. Then you turn, and there it is, a patch of space darker than the void around it, a perfect circle where even the stars seem to vanish. As you watch, the darkness pulses like a throat swallowing. That's when the terror sets in, not because of what you see, but because of what you don't. Or maybe you're a radio astronomer, hunched over a console in the dead of night when your array picks up an anomaly. At first, it's just another data blip until you realize it's not a signal, but the absence of one. A perfect sphere 34 light-years wide where all emissions stop cold. You recalibrate, double-check, but the silence persists. Then, as you stare at the screen, new data scrolls in. The void's edges are shifting, not expanding or contracting, but rippling, as if something beneath the surface is stirring. Your fingers hover over the alert button. Do you report this, or pretend you never saw it? For those who work in space, silence isn't peaceful, it's a warning. A veteran satellite technician once described repairing a comms array when suddenly all telemetry flatlined, not just from the satellite, from the entire quadrant behind it. For 12 minutes, Earth might as well have not existed. Then, just as abruptly, the signals returned. The kicker, ground control, had no record of the outage. To them, transmissions never skipped a beat. Here's the most chilling twist. These aren't just stories. They're composites of real accounts from pilots, astronomers, and engineers who have brushed against something they couldn't explain. The common thread: time behaves differently near the zone. One pilot swore his 5-minute blackout lasted hours internally, yet his clock disagreed. A Mars rover team once watched their feed glitch as the planet's orbit carried it, behind the zone's projected path. The rover's final transmission before signal loss wasn't static. It was a single, looping scream from its collision alarm, a scream no one heard until playback because the live feed had already gone silent. This is the horror of the silence zone. It doesn't just erase signals, it edits reality's tape, and the more we listen, the more we realize the silence isn't empty. It's waiting, so the next time you gaze at the night sky, remember somewhere out there a patch of stars is lying, because the scariest thing in the universe isn't the unknown. It's the certainty that something unknown is staring back, and it's learning to hide. Not every scientist believes the silence zone is a cosmic mystery worth losing sleep over. Skeptics argue that what we're seeing could be nothing more than a colossal blind spot, a perfect storm of instrument limitations and cosmic bad luck. After all, space is vast, and our technology, while impressive, is far from infallible. Could this void simply be a gap in our data, a phantom conjured by overlapping errors? It's a compelling counterargument, and one that deserves serious scrutiny. Take radio interference, for example. Earth's atmosphere is a noisy place, crackling with natural radio emissions from lightning, solar flares, and even human-made signals bleeding into scientific observations. Some critics suggest the zone might just be a dead zone in our own detection methods, a frequency range where our telescopes accidentally cancel out real signals due to calibration quirks. This isn't pure speculation. In 2018, a team at the Green Bank Telescope discovered that a software bug had been mislabeling certain cosmic radio waves as static, creating artificial, silent patches in their data. For a brief moment, it seemed like a smoking gun until follow-up observations from Chile and Australia confirmed the zone's existence independently. You can't blame the same software bug on 3 different continents. Then there's the shadow effect theory. Certain dense interstellar clouds, like the Taurus molecular cloud, are notorious for blocking light and radio waves. If an unusually thick pocket of cosmic dust happened to drift between Earth and the zone's location, It could theoretically mimic the zone's signal-swallowing properties. But here's the problem. Dust clouds don't block everything. They scatter and absorb light unevenly, leaving telltale fingerprints in the form of infrared radiation or subtle changes in background starlight. The silence zone doesn't just dim signals, it annihilates them across all wavelengths, from radio to gamma rays, with no residual heat or scattered particles. Even the darkest nebula can't pull off that trick. Perhaps the most persistent skeptic argument revolves around sampling bias. The universe is mind-bogglingly large, and statistically, somewhere out there ought to be regions where, just by sheer chance, no stars, no galaxies, and no signals intersect. In this view, the zone isn't an anomaly, it's a cosmic coincidence, a blank canvas in an otherwise crowded stellar gallery. But coincidence doesn't explain the zone's razor-sharp boundaries or its eerie ability to adapt to our probes. Random voids don't learn, they don't echo prime numbers, and they certainly don't consistently erase signals from multiple unrelated experiments over decades. The nail in the coffin for pure skepticism: time discrepancies. When the European Space Agency's Harmonia probe grazed the zone's edge in 2021, its atomic clock desynchronized from Earth's by 3.8 seconds, an error far outside normal drift margins. Instrument glitches don't warp time, data gaps don't rewrite causality. Whatever the silence zone is, it's not just a trick of the data. It's a phenomenon that actively defies the rules we've spent centuries writing. And that's what makes it so terrifying, not because it might not exist, but because the evidence insists it does. The future of the silence zone isn't just a question of scientific curiosity. It's a puzzle with implications that could rewrite our understanding of reality. Right now, the zone drifts silently through the Orion Arm, a perfect sphere of nothingness that devours every signal we throw at it. But what happens next? Will it remain static, a cosmic oddity frozen in time? Or is it changing even as we study it, evolving in ways we can't yet comprehend? One possibility is expansion. The zone's edges show faint ripples in space-time, like the surface tension of a bubble moments before it pops. If these ripples aren't just artifacts of observation but signs of instability, the void could be growing, slowly swallowing more of the cosmos into its perfect silence. Imagine a scenario where, over centuries, the zone's diameter doubles, then triples, consuming star systems in its path. Astronomers tracking nearby pulsars have already noted subtle timing irregularities in their pulses when aligned with the zone's current trajectory, as if space-time itself is subtly warping ahead of it. If this is a precursor to expansion, the consequences are staggering. Not only would we lose the ability to observe parts of our galactic neighborhood, but civilizations in those regions, if they exist, would vanish from the cosmic conversation without a trace. But expansion isn't the only path. The zone could also be decaying. Quantum fluctuations at its edges might hint at an eventual breakdown, a gradual unraveling of whatever force or structure maintains its unnatural silence. In this scenario, the void wouldn't grow, it would collapse, dissipating like fog under sunlight. The first sign might be a faint glimmer of radio noise at its periphery, a crack in the cosmic mute button. For scientists, this would be a bittersweet revelation. On one hand, the mystery would finally yield answers. On the other, the zone's disappearance could mean losing the chance to ever understand it fully. There's even a haunting third option. What if the zone isn't permanent at all, but a transient phenomenon, a cosmic storm that periodically forms and dissolves? Ancient star maps hint at similar voids appearing and vanishing over millennia, like celestial will-o'-the-wisps. If true, we might be witnessing just one cycle in a process older than humanity itself. Then there's the tantalizing and terrifying prospect of revelation. With next-generation telescopes like the Square Kilometre Array coming online, we might finally pierce the zone's defenses. Advanced quantum sensors could detect minute gravitational anomalies or fluctuations in the fabric of spacetime that earlier instruments missed. The James Webb Space Telescope's successor, currently in development, might peer beyond the visible spectrum, catching glimpses of structures or energy patterns hidden within the void. And if breakthrough Starshot's microprobes ever breach the boundary, their nanoscale sensors could transmit data from inside the silence before it erases them. The payoff, either proof of a natural phenomenon beyond known physics or evidence that the zone is something far more deliberate, but revelation carries risks. Every probe we've sent so far has either vanished or returned altered, its data corrupted or its behavior unrecognizable. What if the zone doesn't just hide secrets but reacts to intrusion? Earlier experiments showed it learning from our signals, adjusting absorption rates, echoing back distorted fragments. A more aggressive approach might provoke a more aggressive response. Some theorists warn of a feedback loop. The harder we push, the more the void pushes back, optimizing its defenses until even passive observation becomes impossible. It's a cosmic catch-22. The only way to understand the zone might be to risk making it permanently unknowable. The ultimate wildcard, time. The zone's temporal distortions suggest its relationship with causality isn't just broken, it's fluid. If time inside the void flows differently than outside, our future observations might intersect with its past or future states, creating a kaleidoscope of contradictory data. A probe entering today could emerge a century from now, or a century ago, its impact already woven into historical records we've yet to decipher. The zone might not just evolve in the conventional sense, it could phase in and out of alignment with our timeline, appearing and disappearing like a ghost in the cosmic machine. Whatever comes next, one thing is certain: the silent zone won't remain static. Whether it expands, collapses, or unravels its secrets under our scrutiny, its existence has already forced us to confront the limits of our knowledge. And that's the real lesson here, not just about a patch of quiet space, but about the universe's capacity to defy our understanding. Because the scariest possibility isn't that the zone changes. It's that it doesn't, and we're the ones who have to. The silent zone remains one of the most unsettling puzzles in modern astronomy, a place where the universe's rules seem to unravel, where signals vanish without a trace, and where even time itself stutters under the weight of the unknown. We've probed it with radio waves, lasers, and even whispers of prime numbers, only to be met with perfect silence, or worse, echoes that feel like something listening. Whether it's a cosmic glitch, an alien artifact, or something beyond our current physics, this void forces us to confront a humbling truth. There are corners of reality we still can't explain. But here's the thing: mysteries like this aren't just scientific dead ends. They're invitations. Every unanswered question about the zone sparks new theories, new experiments, and new ways of seeing the cosmos. Maybe you think it's a natural phenomenon we haven't discovered yet, a quantum vacuum or a dark matter anomaly. Or maybe you're convinced it's evidence of something far more intentional, a cosmic keep-out sign left by civilizations older than stars. Whatever your take, drop it in the comments. The best part of these enigmas isn't just solving them, it's the wild, collaborative brainstorming that happens along the way. And if you're hungry for more cosmic riddles, don't worry, the universe is full of them. Coming up, we'll dive into other unsolved space phenomena, like the eerie fast radio bursts that ping Earth from deep space, or the bizarre ghost stars that vanish without a trace. Because here's the real kicker: the silent zone isn't the only place where the universe doesn't play by the rules. It's just the one that reminds us every time we look up that the cosmos holds secrets we're only beginning to whisper about. So stay curious, keep questioning, and remember, sometimes the most profound answers aren't found in the noise but in the silence between